What are neural networks and how do they work? Now, I'll tell you right off the bat, this will take me longer than 60 seconds or 100 seconds. Reason being, I like to explain neural networks through the genealogy of their development over almost 6 decades. Neural networks are a cornerstone in the field of artificial intelligence that date back to the mid-20th century. If you look at the early theoretical foundations from McCullough and Pitts, where they produced or proposed a model for neurons in their paper, The Logical Calculus of Ideas, Immanent in Nervous Activity. Now, this paper described how neural networks could implement logical operations and computations, and in many ways was sort of the baseline that got established. Then we have the Hebbian rule. This was defined in the work of Donald Hebb in his book, The Organization of Behavior. And this is from 1949 or somewhere thereabouts. And he posited the notion that neural pathways strengthen from repeated activation. Now, this concept is important. It's also known as the Hebbian learning, and is often summarized by the phrase, cells that fire together, wire together. And then an important moment for modern-day neural structures was the development of the perceptron. This was developed by Rosenblatt in around 1958 or 1959. Now, the key element here was one that, for the first time, we had a neural network capable of binary classification. And secondarily, it was a model inspired by the structure and function of biological neurons. Then we had further refinement and development by Minsky and by Papert in their book called Perceptrons, and this is the late 60s, I believe it was 69. It was then, post that period, with a lot of iterations back and forth, that in 1986, where I think it's safe to say that we have a seminal moment, similar in its importance to the 2017 transformer network design from the folks at Google Brain. In 1986, we have Hinton, Rumelhart, and Williams introduce us to this concept called backpropagation algorithm. So what they did was they basically gave us, for the first time, the ability to effectively train multi-layer neural networks. Their paper was called Learning Representations by Backpropagating Errors, and I would really hope that some of you would look that paper up and read it. It's quite an interesting piece of work. And then finally, in the 2000s, we jump into deep neural networks. These are RNNs, CNNs, and so on and so forth. So 40s was about theoretical constructs. In the 50s, we get the perceptrons. In the 60s, you get refinements on the perceptrons. In the 80s, we get backpropagation. And with that, soon enough, we are in this world of multi-layer neural networks, leading us to the current modern representations of neural networks. Now, with all that preamble, let me dive into neural networks themselves. So neural networks are computational models that in many ways are inspired by the human brain structure. And they're consistent of and are structured around what are called interconnected layers or nodes. You can also call them neurons. Now, each neuron processes input data and then passes the output to subsequent layers of nodes and neurons. The network typically includes an input layer, one or more hidden layers, and an output layer. So neurons in each layer are connected via what are called weighted edges. And during training, the network adjusts to these weights using algorithms like backpropagation to minimize any error in predictions. Now, neural networks also excel at pattern recognition tasks, such as image and speech recognition, by learning complex mappings from input to output through iterative training on larger data sets. Now, in my answer, there are likely 2 questions that arise. What are hidden layers and what are weighted edges? And those are questions we'll address at a later time.